Hello, my name is Vishal. I'm going to give a presentation on the hardware, and my partner Kiran is going to explain the GUI. This is a presentation of a tooling robot. In this video, we are going to talk about the hardware used, the axis, and the DH parameters. Firstly, the hardware used in this project are two servo motors, the two metal bars, mountings for the servo motors. The motors are set in such a way that the robot gains a maximum reach on the clipboard. The z-axis is along the rotation and the x-axis is perpendicular to the z-axis. The metal bars are set at different angles and the DH parameters are calculated. And from now, the GUI will be explained by Kiran.
Yeah, now I'll go with the GUI. Firstly, I would like to run the GUI file from the editor. And now, if I run the editor first, I designed a few things with an axis and one x-axis, y-axis, and two sliders, and a button for end effector and a push button to start the robot. So when I run the GUI.m and hit the push button, I'll get the tooling robot. So I can change the toolings of the robot. And now coming to the end effector calculation, we can have two different angles. Let us suppose 45 and minus 45. And now you can see the x-axis position. I mean the end effector position is like on x-axis is 18.4 and 7.60 on y-axis. So I even compared this with the MDL Puma 560, because in Puma 560 we have 6 links, but this is a 2-link robot. So, and coming to the code, so I used the slider function and the callback for that as handles.robot.plot, handles a dot handles b, and the calculation for the n factor is here. I took the default L1 is equal to 10.8 and L2 is equal to 10.8, and the calculation for theta is with the formulae, and for x and y, and finally I put the values into the x and y axis on the GUI from handles.x axis and handles.y axis. And this is the way we made the GUI with the tooling robot and getting the end effector. And this is how we made the tooling robot.